A piecewise function is a function that is made up of individual pieces. Each piece of the function has a different equation and domain. Graphing a piecewise function is very similar to graphing more than one equation on the same graph, with an important difference. Because all of the pieces cumulatively create a single function, the graphs never intersect or overlap vertically. When you graph a piecewise function, this is what it's going to look like, the actual function. This function has three pieces, so each sub-equation. Each piece has a different domain interval listed from smallest to largest. So if I look at this, this is the equivalent of having y equals 2x when x is less than 1. So that's part of the equation. The next one would be y equals 5 when x is between 1 and 4. And 4 would be open circle, 1 would be a closed circle. Oops, you can't see that. And then the last one is the equivalent of y equals negative x when x is greater than or equal to 4. I'm going to zoom out just a teeny tiny bit. So, notice that the cumulative domain intervals cover all your values from negative infinity to positive infinity. So this is up to, but not including 1. This is 1 to 4, but not including 4. And then from 4 to infinity with 4 included. So, this is often the case, but not required. Most of the time we will go from negative infinity to positive infinity. There are also breakpoints between the equations. So the breakpoint is where an x value, where the pattern of the y values change. So a piecewise function with n pieces has n minus 1 breakpoints. So if we look at this one, we have a breakpoint at 1, and we have a breakpoint at 4. So we have 3 equations here, or 3 pieces, so we have 2 breakpoints. So we have 1 fewer breakpoint than we do pieces. So, on our example one, when x equals 1, the graph changes from y equals 2x to y equals 5. Then again, when it changes here, this breakpoint, when x equals 4, the graph changes from y equals 5 to y equals negative x. So, when you're graphing this, this is my recommendation for this. Make sure, one, that you are using pencil, because it's really, really easy to make mistakes on this kind of stuff. The first one, our first breakpoint is at 1, so I'm just going to do a light vertical line at 1. And then my second breakpoint is at 4. My first graph is y equals, whoops, you can't see that. My first piece is y equals 2x when x is less than 1. So on this graph, on this side of my first breakpoint is where I'm going to have that. So the graph y equals 2x has a slope, a y-intercept of 0 and a slope of 2. So if I were to draw this whole thing, I would just draw it straight down, but I'm going to start here where x equals 1. So we also have x is less than 1, so I'm going to do an open circle there. And then line it up, better than that, and draw my arrow going down. So that line is y equals 2x, where x is less than 1. And make sure you're really obvious, really clear in your closed circles and your open circles. The next part of that piecewise function is f of x, or y equals 5. So what kind of line is that going to be when we have y equals a number? Straight horizontal line. So y equals 5 between 1 and 4. 1 is included, so I'm going to have a closed circle there, and 4 is excluded. So I'm going to have an open circle there. And then I draw the line between them. Everybody with me so far? Okay. And then the last part, y equals negative x, for x is greater than greater than 4, greater than or equal to 4. When I graph y equals negative x, I am going down 1 and over 1 repeatedly. Trying to get that line up right. So, but I'm not going to start it until x is greater than or equal to 4. So I'm going to make a closed circle at x equals 4, line it up again, and then draw my arrow going out. So that is my piecewise function. So notice that, go ahead and erase my vertical lines at my breakpoints. Notice that whenever I have an overlapping point, so here and here, 1 is not included for this function, but it is included for this one. 4 is not included for this one, but it is included for this one. So those three parts all make a piecewise function. So down at the very, very bottom, when I'm evaluating a piecewise function, I need to remember that I'm only using one part of that. I'm only using one piece of that function. So sometimes I can find this from the graph, and sometimes I have to use the equation. So for f of negative 5, remember that's the same as when x equals 5. So where x equals negative 5, I'm going to go all the way down. So I drew that one really badly. So if I check back at my equation, where x is less than 1, y equals 2x. So if x is negative 5, this is going to be 2 times negative 5, which is going to give me negative 10. For f of negative 20, that's again that first part where x is less than 1. So 2 times negative 20, so negative 40. So definitely a situation where you can't use the graph. For f of 1, this one I can use the graph. So x equals 1 right here and all along this line. So y is going to equal 5. For f of 4, can't be 5 anymore, so it has to be negative 4. For 19, we can't see that on the graph, so we have to look at what piece of our function this applies to. So x is greater than or equal to 4 for that third piece. So I'm going to plug in 19 for x. So that means that my f of 19 is going to be negative 19. So we already figured out, we already did one example where you guys were drawing the graph. So we also want to do one where you're figuring out what that part is. So basically what we need here are our equations. So if you just look at this right here, what graph is that going to be? First of all, what equation? It's a quadratic. It's parabola, right? And we have a parabola with a vertex of 0, 0. And then it's going down, out 1 and down 2. Which means if I don't look at my domain restrictions at all, this has an equation of y equals negative 2x squared. So I was corrected on that one. I wasn't paying attention to the scale. So we're actually going out 1 and down 1, and out 1 and down 3. So this is not 2. This is just negative x squared. So that's one of our equations. The other one, we need to look at this in terms of going all the way back to our y-intercept, which is going to be at 4, and this is just a linear equation. So this is going to be y equals 2x, because we go up 2 and over 1 repeatedly, and then minus 4. No, I did it again, didn't I? No, that's right. It's 2x. Right? Right. Okay. See, now I'm all screwed up. Okay. So now we need to put the domain restrictions in there. So we need to specify what values our parabola covers. So what's our lowest x value on the parabola? Negative 3 is going to be less than or equal to, because we have a solid dot there. And then our highest value for the parabola is 2. And because that's an open circle, we're going to look like that. So it's the equation and then the domain restriction. And then this part, our lowest value for your x's is 2. That's a filled in circle, so it's less than or equal to x, which is less than or equal to 6. Okay, so how we're actually going to write this is f of x in our little bracket, negative x squared if x is between negative 3 and 2, 2 not included, and then 2x minus 4 if x is between 2 and 2 and positive 6, both included. So that is writing a piecewise function. Figuring out your equation if it was normal, and then determining the domain restrictions.